Alright, hi you guys. This is 3.1, Analyzing Tidal Data Lab. I want you to know that this is the first page. If you continue to scroll down, you're going to find this tide chart. This tide chart is for the whole month from the 1st to the 30th of November, Ocean Shores, in a beach in Washington coast. And I'm going to go through questions 1, 2, 3, 4, and 5 with you. So the first question says, a high tide occurs when the tide reaches its maximum or lowest height. The correct answer is maximum. When the ocean rises, it's at its maximum height. Number 2 says, how many high tides normally occur in ocean shores in 24 hours? If we look at, let's pick day 1, November 1st. We have a low tide, a high tide, a low tide, and a high tide. So in one day, we have 1, 2 high tides. Number 3 says, a low tide occurs when the tide reaches its maximum or lowest height. Correct answer is lowest. It's when the ocean level lowers. Number 4, how many low tides occur on ocean shores in 24 hours? If you look back at November 1st, we can see there's a low tide, high tide, low tide, and high tide. So there's 2 low tides that occur 24 hours. Number 5, why do you think this pattern in high and low tides exist? Well, it's because of Earth's rotation.
All right, so the next question asks us to examine the height of the tides from November 12th through November 17th. So here's November 12th, and there's November 17th. So we're looking at the tides right here in this section. And we're looking at the high tide, and I want to focus just on the first high tide to keep it simple. So I'm just going to be looking at this data right here. Now, the first question says, how does the height of the high tide change from tide to tide? So 8.4, 8.8, 9 feet 2 inches, 9 feet 7 inches, 9 feet 11, 10 feet 2 inches. So it's getting higher and higher. So over here, how does it change? The height gets higher and higher, which, there we go, higher. So now I'm going to compare the times that the high tide and low tide occurs over a 2-week period. So daylight savings time was on November 7th. So we're going to do here. We're going to start after daylight savings time so that we're looking at the same time of the tides each time. So I'm going to go from the 7th now all the way down here for 2 weeks to like the 21st-ish down there. And I'm going to be looking at the high tides and the times that they occur. So high tide is happening right here, and then there's low tide and high tide. And I'm just going to focus on the first tides of the day. So if I look at the first high tide on the 7th, it's at 2:36 a.m. Then the next high tide the next day is at 3:32. So again, it's getting later and later in the day, right? As I go down, my high tide is getting later and later in the day. And then here we switch to low tide, my high tide's over here, but it's still later and later in the day. Now if I look at my low tides, same thing. It's getting from where daylight savings time started, so here it's getting later and later and later each day, okay? Starting right about there with our data. Later and later, and then back to the next low tide over here, later and later. So the tides are happening a little bit later each day. Why do we think this is happening? That's the big question. So think about that and see if you can come up with an answer. All right, so now we're going to examine the moon rise and moon set times. So here's our moon rise and moon set times, and we're going to start here with the 7th, and we're going to look down this way. And so what we see is that the moon is rising a little bit later each day, and the moon is setting a little bit later each day. So if I compare these to the high and low tides, so if I look in close at the data and when it's graphed, so here's my moon set time. And notice that it correlates directly with a low tide. And here's my moon rise time, and it's just below a high tide. So that's how those patterns are related. We've got moon set is going to be at a low tide, and just after moon rise will be a high tide. All right, so the high tide is just after moon rise, and the low tide is just after moon set. So what's the reason behind these patterns? Well, it's because tides are controlled by the moon. So what we're going to write here is the moon's gravitational pull is what controls the tides. All right, so now it asks us to examine the data about how much of the moon is visible with the lunar phases and compare the moon phase to the heights of the high tide and the low tide. So this is the moon phase information for the month of November in Ocean Shores. So new moon is on November 4th, first quarter moon is on November 11th, full moon is on November 19th, and third quarter moon is on November 27th. And we're gonna write that in on our tide data and use that to answer these questions. All right, so November 4th is new moon. So we're gonna be looking at this data right here with November 4th. And then November 11th was the first quarter moon. So we'll be looking at this data. And November 19th is the full moon. So we'll be looking at this data, and I'll get out of your way here in just a second so that you can see the data. And then November 27th is the third quarter. So with new moon, we notice, and let's just focus on this second high tide and this second low tide. So we're going to focus on the highest ones. This is a really high tide. It's 11 feet 1 inch. And this is a really low tide. It's negative 1.3. So that's at new moon. Now with first quarter moon, we can see that we have this high tide right here of 8.6. That low tide doesn't exist, but here it's 4.4, okay, because that low tide actually happens on the next day. So we can see that it's not a very low tide. And then if we look at the full moon, we have a really high tide again at 10.3, and we have a low tide that's negative again at negative 0.4 or negative 4 inches. And then when we look at our third quarter, again, we don't have this other tide here, but if we look at this low tide, it's 4.6. And if we look at the high tide, it is, the highest one is 8 feet, but this one here is 7.7. So we notice that at the new moon and the full moon, there's a bigger difference between the tides, right? There's a lot more water moving than at first and third moon. So during which phase do the lowest high tides occur? Well, the lowest high tide, third quarter, right here. So we're gonna write third quarter, because that's our lowest high tide. And then during which phase do the highest high tides occur? Well, the highest high tide occurs at new moon. So what would the reason be behind these patterns? What else is there that could line up with the sun-earth-moon system during new moon that might affect the tides? Well, obviously that's the sun. So both the sun and the moon's gravitational pull affects the tides. And I'm going to write that in right here. rewritten the phase of the moon and the highest and lowest tide on each day, so we can ignore all that extra data that we're not going to graph, and we can focus on graphing our moon data. So the first thing we need to do is we need to set up our graph. So along the bottom is going to be the moon phase. So this will be moon phase. With date. And on the side, we are going to graph the tide height. So just for the bottom, I'm going to go over 4 spaces, 1, 2, 3, 4, because this is going to be my new moon, and I'm just going to draw a solid dark moon for new moon, and this happened on November 4th. Now, over 11 spaces, so this is 11 from my origin, is going to be my first quarter moon. So there's my first quarter moon, and this happened on November 11th, or will happen on November 11th. Then on the 19th, we are going to have a full moon. And so that is going to be 11/19 for the full moon. And then on the 27th, we are going to have a third quarter moon. So the light is going to be on the left side, and that's going to be 11/27. And so we're just going to graph 4 points of data from the tide chart. Now on the height, we have a negative tide, and it goes all the way up to a positive tide of over 11 feet. So this right here is going to be -3, and then I'm going to skip 2 places, and I'm going to just go up like that. All right. So on November 4th, my highest high tide was at 11 feet 1 inch. So I'm going to go to November 4th, and I'm going to go up to 11 feet, and just above 11 feet, I'm going to put a dot. Now my lowest tide was negative, so I'm going to be down here in the negative, 1 foot 3 inches. So that dot's going to go right here, halfway between 1 foot and 1.5 feet. Now, moving on to my first quarter moon. My highest tide was at 8 feet 6 inches. So I go up to 8 feet 6 inches, and I place a dot there for my high tide. My low tide was not very low at this point. It was only 4 feet 4 inches. So it's going to be right here, just below 4.5. Now at full moon, my high tide is going to be big again. It's going to go all the way up to 10 feet 3 inches. So right here, halfway between 10 and 10.5. And then my low tide is going to be negative again. So it's going to be just below the 0. It's only 4 inches negative, so it'll be right, whoops, make sure I'm in the right spot here, right there. Yes. Now the final bits of data that we need to graph are at our third quarter moon. So that again is when the high tide is not as high. And so it's at 8 feet even, which is going to be right here. And then my low tide is not very low at all. It's at 4.5 feet. So it's going to be right there. So I have all these random dots, and they probably don't make a whole lot of sense, but if I connect the low tide dots, this shows my low tide over the course of the month. This is the height of the low tide over the course of the month. And if I connect my high tide dots, or points, then this shows my high tide over the course of the month and the height of my high tide. And so what we see is that new moon just like we predicted, there is the greatest difference between high and low tide. And then at third quarter moon, just like we predicted, the graph shows us that there's the smallest difference in that tidal movement, okay? So it's the smallest distance between, just like we predicted with the previous questions, 10, 11, and 12. So we're gonna write a summary sentence here that the tides are caused by the moons and suns combined gravitational pull. And so what that means, if you remember back to our lunar phases lesson, in new moon we have sun, moon, earth, and they're all in a line and everything is pulling one way, which is why we're going to get this really big tide, okay? And this is also called a spring tide. We're going to get this huge tidal difference because everything's in a line and it's all pulling the same way. Full moon, we still get another big tide because everything's in a straight line. This is also called spring tide, but it's not as big because it's not all pulling in the same direction. Now with third quarter moon, so if we have new moon, so here's our sun, here is our earth, and here's our moon. The moon is pulling on the water and the sun is pulling on the water. So we have a big bulge at new moon. And so this is new moon. Now at third quarter, where we have our lowest high tide, we still have our sun. And we have the earth here. But now our moon is located up here in the third quarter position. And so the moon is pulling on the water this way, but the sun is pulling on the water this way. So that's why we end up with those lower high tides and higher low tides, is because the gravitational force isn't aligned. So the tides, again, are caused by a combination of the moon's gravity and the sun's gravity on the water on our planet.